device that converts heat energy to mechanical work is called a heat engine. All heat engines make use of a substance inside them that undergoes cooling and or heating, compression and or expansion, and sometimes change of pace. This substance is called the working substance of the engine. For example, the working substance in a steam engine is water. For the gasoline engine is the gasoline-air mixture. Basically, all heat engines follow this pattern of operation. A. Heat is supplied to the engine by an external source called hot reservoir or heat source. B. Part of this heat is used to do work on an object. C. The rest of the heat is released at a temperature lower than the input temperature to an external place called the cold reservoir or the heat sink. All engines follow a series of processes at the end of which it is returned to its initial state. This series of processes is called a cycle. Heat engines may be classified into two major types: internal combustion engine and external combustion engine. An internal combustion engine burns the fuel inside the engine. External combustion engine burns fuel outside the engine. Auto engines and diesel engines are internal combustion engines. Steam engines are external combustion engines.
Steam engines. Since ancient times, man has made practical use of heat. A hero of Alexandria invented the oldest heat engine in 200 BC. He called his invention aleopile, in which steam was conducted through pipes from a boiler. The steam in turn caused a sphere to rotate. Hero's steam engine was invented to be a toy only. Thomas Savery developed the first commercial steam engine in 1698. However, the engine used steam at a high pressure and had the disadvantage of high risk of boiler or cylinder explosions. Thomas Newcomen came up with the modified engine using steam at atmospheric pressure in 1712. James Watt introduced a greatly improved steam engine with a separate condenser in 1769. This invention triggered the so-called Industrial Revolution and stimulated the inventions of other types of engines like the steam engine, the gasoline engine, diesel engine, and jet engines. The operating cycle of a steam engine is shown here. Water is pumped to a boiler where it is vaporized. The steam is admitted into a cylinder where it expands. The expanding steam pushes a piston doing work in the process. The spent steam is then discharged to a condenser and returned into the boiler. In some steam engines, the steam or the spent steam is just discharged into the atmosphere.
The gasoline engine and the diesel engine are internal combustion engines. These engines operate on 4 different steps on strokes, namely intake, compression, power, and exhaust. All these steps happen inside a hollow cylinder. Modern-day vehicles have 4 or more cylinders. Each cylinder is equipped with valves that open to admit air-fuel mixture into the cylinder and to release exhaust gases. The gasoline engine is also known as the Otto engine. The Otto engine was first proposed by French scientist Alphonse Briot de Rochas in 1862 and was built by German engineer Nikolaus Otto in 1877. Rudolf Diesel designed and obtained a patent for his diesel engine in 1891.
Ideal heat engine and efficiency. How much of the input is converted to work determines the efficiency of a heat engine. The efficiency of heat engine is efficiency is equal to work over heat input times 100%. The human body is considered as a heat engine, with food as our main source of energy. However, only 20 to 30% of this energy is converted to useful work.
Go! Maximum efficiency is obtained if all the processes undergone by the working substance of a heat engine are reversible. This statement is called Carnot principle, named after French engineer Sadi Carnot. The efficiency of a car engine whose hot reservoir is a temperature of T sub H and whose cold reservoir is a temperature of T sub C is given by efficiency T is equal to T sub H minus T sub C all over T sub H multiplied by 100.